Hi, good morning. We are 5 minutes to 9:30. So I think thank you for being early. And maybe we can even start a bit earlier on the introduction before 9:30 itself. All right? Okay. Sawadee Kap. Sawadee Mai. Pom Chu Eddie Ko, FAE Manager, Majak, Singapore. And that's all the Thai that I know. The rest of the Thai I know is more on the food, ordering food to eat. All right. So once again, thank you and welcome to TI Tech Day, Thailand 2025. Okay. So we have a lineup of our agenda for you today. For the morning is more on the embedded processing side, and afternoon is a lot more on the analog side. Okay, so it's a full day of agenda for you. And for the opening, I'd like to introduce TI to you. So TI, stands for Texas Instruments. Our headquarters is in Texas. Our wafer fab is in Texas. Our R&D, about 14,000 people are in Texas. All right, so that's why we are called Texas Instruments. In last year, we did about $15.64 billion of revenue. Okay, it's down from our record of 20 billion during the 2 years ago semiconductor peak cycle. Okay, and overall, one thing you want to focus about TI is that about 70% of our business, okay, is focused on industrial and automotive. Okay, so what does this show us about TI? We are not here to chase the personal electronics business where it goes up and down and then the product go EOL. Right? To support our customer in industrial applications, we know that you need 10 years, 15 years, even 20 years product life. Okay? To support our customers in automotive, we know you need high quality, automotive grade, Q100, high reliability, very low failure rate. So TI, we are in this business. Long lifespan, high quality, low failure rate. That is what TI is focused on. Okay? But we also do a little bit of personal electronics, 20% of our business. Because our products are so established in the industrial and automotive space, it can be also used for personal electronics. And for personal electronics, what is the focus that you need? You need short lead time, right? You launch a product, you don't know your customers will buy a lot or buy very little. So what you need is short lead time, very dynamic ordering system. And this is one thing that TI is committed as well, okay? It is our company policy to maintain at least 200 days of inventory so that we can support any market surge that comes up. All right. So 2 years ago, we learned our lesson from the semiconductor shortage. We want to fix that with 200 days of lead time at TI. We know that customers don't want to hold inventory. You want to keep it in your warehouse. We keep it for you. We keep 200 days of inventory so that we can support short lead time orders from you. Okay. So that's a brief overview of TI. Yep, about 14,000 people in America. 2,000 in Europe, mainly on the R&D side. We have one fab there. And the rest in Asia Pacific, we have our warehouse, we have our assembly and test, as well as a few R&D sites as well. Okay, so this is TI values. Okay, there's two things I want you to remember for today. We're going to have a lot of technical presentation the whole day, but two key things I want you to remember about TI. The first thing is TI's ambition. Our ambition is to create a better world by making electronics more affordable through semiconductors. Now, you know the semiconductor industry, not just TI. The whole semiconductor industry, we are good at making things cheaper, smaller, better. Okay? So we are always doing that in semiconductor industry. But that by ourselves is not enough. We need to partner with all of you because all of you can make the electronics more affordable. When you use the latest technologies from TI, more integration, it will bring down the cost of your product. Okay? And with that, we make electronics more affordable for the whole world. Be it a medical equipment, be it a robotics arm, be it a power supply, we make electronics more affordable. And when electronics is more affordable, okay, the world become a better place, right? Can you imagine in the past, a medical equipment that cost $10,000, now you can have it at home for less than $1,000, and it improves your life so much. In the past, you need to have a lot of workers in the factory to do very manual work or dangerous work. Now you can have robotics that are affordable to make life better for everybody, right? And power supply that is more efficient, smaller size, less thermal, less losses, so that we use less energy to achieve the same thing. So that is why TI, we need to partner with all of you. to make the world a better place for everybody. So that's the first thing I want you to remember, all right? And the second thing I want you to remember, okay? Before I tell you the second point, let me ask a quiz. When you think of TI, which product do you think TI sells? Op-amps? Converters? Wi-Fi? Everything. Yes, that's the point. Remember this point. TI sells everything in semiconductor space, all right? If there's a product that you're trying to design, you think that TI doesn't have it, look for me, look for TI. Test us, ask us whether we have it or not. You'll be surprised some things that you don't know that TI have, all right? I know you know that TI, we have embedded processor, microcontroller, DSP processor. You know TI have amplifiers a lot, okay? We have thousands of amplifiers. I cannot memorize all the part numbers. Okay, in fact, TI, we have 80,000 part numbers, okay? We call it generic part numbers, 80,000 generic part numbers. Auditable part numbers is more than that, way more than that, all right? And you know TI is good at data converters. Not just the low cost, not just the low speed. We are doing RF data converters as well. Analog front end for 5G base stations, aerospace and defense, we are doing that. Okay, we have a lot of interfaces, right? RS-232, 485, and so forth. USB Type-C, PD. We have Wi-Fi, Bluetooth. Okay, we have a power supply, buck boost, linear power, LDO, voltage reference. We also have battery management, right? Not just for cell phone, not just for laptop, even for cars. Okay, we have automotive grade battery management. Clocks and timing. One thing that many customers always forget, they don't know TI have clocks, all right? We not just have the normal clocks, you know, like crystal to oscillators and so forth. We have a technology called BAW. It's called a bulk acoustic wave. We use that to generate a frequency. So that's how we use a crystalless clock. Okay, we generate clock without a crystal, so there's no mechanical involved. Okay, just for semiconductor alone, right? And we have DLP, right? Maybe most customers don't use this DLP product, but you go to cinemas, you see our product there. Projectors, not sure about this one, but many projectors are DLP based. Okay, we have motor drivers, okay, voltage translation, logic, switches, multiplexers, and one whole category, sensors. TI is investing a lot of money in sensors now. Okay, we have simple things like temperature, current sensors. We also have humidity sensor, many magnetic sensor, and even radar applications we have. Okay, 77 gigahertz, 60 gigahertz radar. Okay, so TI is always investing, always having new products. And when you keep up with TI products, you will realize how we can use TI products and technologies to simplify your design, make it smaller, make it cheaper, make it faster. All right? So remember two things. TI's values to make the world a better place by making electronics affordable through semiconductors. And second, TI sells everything. Okay? And that's the overview introduction that I have for today on TI. All right? And now I shall go back to my FAE manager role to talk about technical products. Okay? So the first session for today, supposed to start at 9:30, is TI's embedded processing products overview. Okay? So what is TI's embedded strategy? Okay? You know that TI have a lot of analog products. Our analog strategy is you don't even have to ask or question. It's a very strong portfolio of products from TI. But embedded, sometimes some customers forget that TI is doing MCU. Some customers don't know that TI is doing processors. And it may be like TI was a bit quiet for a few years in terms of embedded processing space. Okay? But no doubt about it, TI is very focused on embedded processing. Okay? We have from 20 megahertz to 2 gigahertz. Or make it more simple, from 10 cents to 2 gigahertz. All right? So as cheap as 10 cent MCU, as high performance as 2 gigahertz processor we have. And it's a full spectrum. ARM Cortex-M0, M33, our AM series here, okay, 13 series for the high performance ARM, M85, our C2000 or the C28 series. We have ARM Cortex-R52, and we have our ARM Cortex-A series with DSP, with AI accelerators. All right, so that will enable you to do even edge AI. That means not the server AI, but the edge AI. And one differentiation about TI is that when you want to buy a microcontroller, it's not just about the processor itself. It's about the peripherals. You need to have good analog and RF integration. So because TI is very strong in analog, we can make very good microcontrollers with high performance ADC, high performance op-amp on the microcontroller. Okay? And with one ecosystem of scalable software and a code reuse, and we are enabling edge AI. Okay? AI is not a big word about ChatGPT, NVIDIA. AI can be very simple in a microcontroller. Depend on what you want the AI to do. So in a microcontroller, you can do a arc fault detection. That means if there's an arcing in your power supply, you can actually use AI algorithms in microcontroller to detect an arc fault. Of course, you cannot use that to generate a Ghibli photograph, okay? But you can use that to detect an arc fault. That's AI as well, right? You can use that to detect variations in your power consumption or voltage and currents to detect preemptive failure. So all these are AI as well. You don't have to be just a cloud-based, server-based AI. So we enable this in TI. Okay. And we also have a comprehensive wireless connectivity solution. Wi-Fi, Bluetooth, Zigbee, Wi-SUN, a lot of RF protocols. So you can see TI has a very broad portfolio of embedded processing products. Next thing, capacity. Now those of you who are in the industry 2 years ago, you will know that there was a huge shortage. It was a very big problem for the whole industry, the whole semiconductor industry. TI was also affected as well, right? And we realized the need to have our own in-house capacity. We cannot just depend on foundries, okay? When we depend, what happened in the shortage? The foundries raise price. And foundry raise price on TI, what do we have to do? We raise price on our customers. And we don't want that to happen. So what we do is, we build our own wafer fab. We build our wafer fab. When there's a shortage, only the substrate costs go up, material costs go up a little bit, we can control our price. We will not take advantage of the situation and raise price on our customers. Okay? So this is what we are changing in our strategy to build more in-house capacity. So by building in TI factory, when the shortage comes, we control the price. We will not have to raise price because our foundry raise price on us. Our foundry can raise price on our competitors, and they can raise price on you, but TI, we can hold our price. That's the advantage that we have by doing in-house and not a fabless company. Okay? So we have this LFab in Lehi. Okay, this is one of the fab in US, but not in Texas, in Lehi, Utah. We have 65 nanometer and 28 nanometer process already. We are building up our Lehi Fab 2, okay, to do 28 nanometers. So our portfolio of MCU is manufactured in-house at Lehi right now. Okay, only for the very advanced nodes. You talk about 5 nanometers, 8 nanometers, then TI will partner with our foundries for the high performance above 1 gigahertz products. Now you ask a question like, why is TI doing 65 nanometer, 45 nanometer, 28? What's the big deal? The whole world is talking about 3 nanometer. Why is TI doing 28 and 65? Let me ask you a very simple question. When you buy a Bluetooth or you buy a microcontroller, how many percent is digital? And how many percent is analog? Okay, I show you the die of a TI. This is our, we call it Lego. This is our Bluetooth 5 device. Okay, Bluetooth 5. 30% digital, 70% analog. If you use 3 nanometer, you're going to have a very lousy RF. All right, you cannot use 3 nanometer for RF. All right, so which is why TI is very focused on the 28 nanometer to 130 nanometer process nodes. This is an area that TI invests in. Okay, in the past 2 years after the semiconductor shortage, you hear about the US CHIPS Act. Everybody invests in wafer fab, a lot of wafer fabs coming up. You think that there will be no shortage? There is no shortage for 5 nanometer. There is no shortage for 3 nanometer. But what about 28 nanometer to 130 nanometer? Very few people are investing. And TI is the world leader in the #1 investor in these process nodes. And this is what matters to you. Because if you look at your design today, ask yourself, how many IC chips you use are 8 nanometer or even 16 nanometer? How many? Maybe at most 1. Okay, if you have a processor that's 1 gigahertz, maybe 1 device on your whole PCB is 16 nanometer. But all the other products, they are analog, they are microcontrollers, they are not 16 nanometers, they are 28 nanometers and above. And this is where TI is investing in the important chips that you are using, all right? Okay, so and in terms of efficiencies wise, yeah, this is just the curve of the cost benefit analysis. So which is why another reason for justifying why 28 nanometers to 130 nanometers is the efficient process for TI to invest in microcontroller space. Okay, and in the long run, TI continue to invest, right? We are not going to stay behind. So beyond our in-house process, 45 nanometer, 65 nanometer, and 28, these are our existing products that we are working on, right? Okay, we also have to partner with TSMC, okay, for 16 nanometer. So when we talk about 1 gigahertz performance, okay, ARM Cortex A53, A72, okay, R5F, okay, and even our C7000 DSP. Okay, this is the one that can run AI, giving you like 32 TOPS of AI processing capability. So that is running 16 nanometer. And we are partnering with a company in Korea, easy to guess, for 8 nanometer technology. And we are looking for 5 nanometer technology solution as well. All right. So for the high performance, we have, but we depend on our foundry partners. For the most of our products, about 90% of TI products, microcontrollers, Wi-Fi, Bluetooth, we have in-house capacity and capability. All right. So beyond A53 and A72, you can see that the next gen will be A35 for low power, A520, and A720 for high performance. Okay. After M4, we are going to M55, M85, and R52. All right. And we continue to extend our DSP products, the 6000 and 7000 series, into a higher generation DSPs. Okay. So you may not be familiar with this product called Jacinto, right? It's automotive grade DSPs, okay, which is commonly used in ADAS, auto parking, self-driving cars. Okay, so this is a technology that TI is using for this market space. All right. And capacity, very important word here is geopolitically dependable. All right. I think the past 1 week, crazy news going around the world. Right. So we are looking at how we can have a more stable and geopolitically resilient supply chain. All right. The world is changing very fast, and everything in TI we are talking about dual source internally. Within TI we have dual source strategy. The same IC chip that we manufacture at Fab A can be manufactured at Fab B. Then after the IC chip is done, can be assembled in assembly and test site A, assembly and test site B. Okay. So we have geopolitically dependable supply chain, okay, across within TI. So if you want dual sourcing, you just TI itself is already dual source internally. Okay, so we have a lot of investments in US. Okay, our 300mm fabs already ramping up is RFab 2 and Lehigh Fab 1. They are already in production, but not yet 100%. So we call it ramping. The other ones, 4 new wafer fabs, all right, in Sherman, Texas, and Lehigh Fab 2. Right now we are constructing the buildings, like Lehigh Fab SM1 and 2. 1 and 2 buildings are finished construction already, and we are installing equipment at Sherman Fab 1 now. Okay, so TI is one company, right, following the shortage, following all the geopolitical risk, we are investing in the range of $4 to $5 billion a year on wafer fab in the process nodes from 28 nanometer to 130 nanometer, which matters to you guys the most. Okay, and not only the wafer fab is in-house, our back end assembly and test is also trying to be more and more in-house. All right. So we are targeting to have about 80% of our assembly and test in-house. So what we are doing is expanding our Malacca and Kuala Lumpur site, okay, to have more capacity to handle assembly and test. So with that, we can supply you embedded processors, analog products with a geopolitically dependable supply chain. All right. So in terms of products, many of you may not be familiar with TI launching a lot of our embedded processor products. Maybe we didn't sell it enough to you guys. You may not be aware. Okay, so I want to categorize them into 5 groups. The first group is microcontroller, MSP. Okay, in the old days, we have this thing called MSP 430. That's our old microcontroller, 16-bit, right? We have moved on to ARM as well. Okay, so now it's our 32-bit ARM Cortex M0. We have a whole series of M0's product launch, starting from 2 years ago, right? From as low cost as 10 cents, from as small as 8-pin WCSP, okay, all the way to automotive grade LCD panel displays, high performance 80 megahertz, okay, microcontrollers, which my colleague Andrew will cover on more details in the later sessions. We also have application-specific MCU. So when we talk about application-specific MCU, we talk about things that have special requirements. You cannot use a general-purpose MCU. So things that you need real-time control for safety, ASIL-D standards for automotive-grade safety standards. You need security, okay, high security management. Or you need high flash memory, up to 128 megabytes. Okay, and also certain special applications like digital power, motor control. You cannot just use a general ARM processor to do it. Okay, it's not powerful enough, it's not efficient enough. All right, you can run an ARM at 400 megahertz to do a motor control, but we can do it in less than 100 megahertz if you use an application-specific microcontroller. Okay, for digital power as well. All right. Okay, I'll skip processor for the time being. I'll jump to connectivity. Okay, again, this will be covered by my colleague Andrew in more detail later. Connectivity. TI has Bluetooth. You guys always know that TI has Bluetooth low energy, and we also have Wi-Fi, and we will have Wi-Fi 6. Okay, so in case you are not familiar with TI, last year we already launched our, or in fact 2 years ago, we already launched our Wi-Fi 6. So TI, we have Wi-Fi 6, dual band, roadmap to tri-band, and we have roadmap to Wi-Fi 7. Okay, and Bluetooth, TI is always a leader in Bluetooth, all right, from very long ago, and we were the test chip for Wi-Fi 5, sorry, for Bluetooth 5, and now we're actually ready for Bluetooth 6, all right? Of course, the spec is not ready yet, but we are the test chip. We are partnering with Bluetooth 6 on Wi-Fi 6, on Bluetooth 6, sorry. Okay, so we also have radar products, okay? And radar products, it's very difficult to design radar. So what we do, because of the antenna design, right? You can design your whole radar system, but you don't have RF experts to design radar antennas. So what we do is we do this concept called launch on LOP, which means you can launch your product directly from the IC chip. Our antenna is on the IC chip. You don't have to design your antenna, all right? So this is how we enable radar for our customers. Okay, so these three, microcontroller, ASM, and connectivity will be covered in more details by my colleague Andrew later. So let me zoom in now to my session, this topic here, on processors. Okay, so we have ARM Cortex A53, A72 processors, right? One of the key areas that after ARM Cortex A8, right, this was quite long ago, we are moving to ARM Cortex A53. So it's our AM62 series. And now there's a new technology that we're doing, it's called SIP, okay, System in Package. We are integrating the DDR into the package, okay, and we also can even integrate the power later on into the PMIC into the package eventually. Also, to let you know, on the high performance side, we have our TDA series, this is our Jacinto series. We can even deliver up to 48 TOPS for vision SoC. Okay, so you have any image processing for machine vision, for autonomous applications, surveillance, up to 48 TOPS of AI capability in our processor. So let me zoom in more into one specific product in our processor category. Okay, it's our AM6 series. All right. So our AM6 series is mainly is an MPU with an on-chip MCU with a lot of supporting a lot of peripherals, input, output, sensors, actuators around the ecosystem. We have a general purpose application product, the AM62 series, 62L, okay? We can do Edge AI, all right? So the clue in TI product, very simple. You see a A means we have the accelerator for AI, okay? A stands for AI. So when we have an A means a processor plus AI accelerator. You see a D means we have a DSP, okay? So we can do audio signal processing or DSP video processing. We also have the 64 series for networking. So when we're talking about gigabit Ethernet, talking about USB 3.0 on chip, this is the series of products for it. Okay? And if you just want to have very high connectivity for real-time control, but you don't need to run Linux, don't need to run A53 at 1 gigahertz kind, the AM243 series will be for real-time control. All right. So yeah, just to show on these products, you can see TI have a very scalable range of solutions. From low tier, AM335 is very popular for the past 10 years. We are moving up to AM62 or 62L series. Okay, 1 core to 4 core or up to dual core with display USB 2.0 and low power consumption. All right. But if you need high performance, the P series and the 67 series can give you up to 4 cores and then up to 50 gigaflops of operations. Okay, so that's the high performance that we have. You need a signal processing extension, we have it as well. You want networking extension with a PCIe USB 3. We also have this series as well. Okay, so this is an overview of what we have on our processor side. If you have any processor requirement that you're using right now, feel free to talk to any of us in TI, and we can present to you in more detail the specs that you need for your various products. All right, so just a block diagram view of what we have over here. right? Up to 4 cores of ARM, Cortex-A53, shared RAM, okay, security acceleration, 1 MCU on chip to handle all your housekeeping functions, right? And a whole suite of connectivity solutions, all right? Together with the display and 3D graphics. So this is our AM62 series. And beyond the processor itself, we have system in package. Okay, one problem with processor is that you need 10-layer PCB, and that's very expensive. It's very hard to do, right? So you're looking for a SOM module, system on module, and that is expensive, right? So one thing in between is what TI is doing. It's called system in package, SIP. What we are doing now, today we started, is to integrate in the DDR. With the DDR in, we can reduce it to 2 to 4 layers PCB. And what we are going to do next is to integrate the power management, PMIC, okay, into a single package. So when you buy a IC chip from TI, it's a single package IC chip, but we have DDR, we have power inside as well. This is where we are heading towards, okay? All right, so you can reduce your PCB complexity, and you don't have to go and buy an expensive SOM. All right, and even SOM, you have reflow problems, right? In a PCB on PCB design. What we're doing is IC chip on PCB. All right, so this is I'll put in the slides for you. All of you who attend the training today, you'll receive the email from TI with the slides, okay, to compare the different series of products from TI, single core to 4 core, cost to performance. All right, so yeah, so this is my summary slide, is that TI is the fastest path to embedded processing development. We have developer zone, software, hardware, training, and our partners, third-party partners, and a lot of online support. And also we are here, physically here with you, and just an email or phone call away. All right. Okay, so that's all I have for my session. Thank you for listening to us, and I'll hand over to my colleague Andrew to go into more detail on the microcontroller, the MSP series, the ASM series, as well as the connectivity solutions from TI. All right, over to Andrew. Yeah.